In our last video, we were solving one-step equations. Now we're going to solve multi-step equations. Basically just the same concept, we're just doing multiple steps in the same problem. So we have to take our time to be a little bit more careful about what we're doing with each example problem. I'm still going to put a red line separating both sides of my equation, just like I did with one-step equations. I'm still going to highlight the variable, and I'm still trying to get x all by itself on this left side of the red line, this side of the equation. Currently, x is not by itself because there's an 11 and there's a -4. Well, mathematically, we want to reverse our order of operations to solve this. We have to go backwards with PEMDAS. We would do our addition and subtraction prior to doing our multiplication and division. But I prefer to look at it and say, which number is x not as close to? X isn't as close to this -4. So the -4 is going to go first. How can I get rid of -4? What's the opposite of subtract 4, or the inverse rather? We're going to add 4 to both sides. Adding 4 cancels it out. What am I left with? 11x equals 33. X is still not by itself. We're not finished with this problem. We still have an 11. Now it's time to get rid of the 11. Remember, it's 11 times x. How do we get rid of times 11? We divide by 11. And we're left with x equals 3 for our final answer. Of course, it's great to check your answers by plugging it back into the problem. In other words, 11x take away 4. I'm going to substitute this in. That gives me 33 take away 4, which equals 29, which is exactly what I hope to get. So I know my answer is correct. Let's try another multi-step problem. Dividing my equation. I'm highlighting my variable. A is extremely close to the 2. They're practically touching. But A is not as close to the -6. So let's add 6 to both sides so that we can cancel out the 6. 4 and 6 are like terms. They're both constants. We can add them together to get 10. On the left, I have 2a. A is my variable. It is still not completely isolated. It's not by itself on the left side because of the 2. How do we get rid of the 2? We divide by 2 on both sides. A equals 5 for my final answer. And again, checking my solution, 2 times A take away 6. A is 5. 2 times 5 is 10. Take away 6 is 4. So my answer checks out. There's our next example. Putting a line down the middle and highlighting my variable. I need to isolate x. I need to get rid of this +7 and I need to get rid of this 8. Since 8 is in the denominator, I'm actually going to get rid of that first. I like to think of this that x and 7 are upstairs, 8 is downstairs, So when it's time for everybody to leave, nobody even realized that 8 was there. 8 can go home first. So we're going to multiply both sides by 8. The 8's cancel, and I'm left with x plus 7 equals 40. Finally, I need to subtract 7 from both sides. X equals 33. Again, we have a fraction situation in this next example. Our variable is in the numerator, but we need to get rid of this denominator first by multiplying by -2. This means divide by -2, so we multiply by -2 to get them to cancel out. On the left side, I have n plus 1, and on the right side, I have a -30. Still trying to isolate my variable, I'm going to subtract 1 from both sides. N is -31. All right, here's our final example today. As we solve these multi-step equations. I'm trying to isolate the p. I'm trying to get p all by itself. P is practically touching 2/3. So we're going to get rid of the -25 first. They're not as close. We're going to add 25 to both sides. I'm left with 2/3 p on the left. And on the right, I have 210. Now again, if you recall from our previous video, whenever we have a fraction with a variable, which we do, we have a fraction that has a numerator and a denominator, we're going to just flip the fraction. Instead of 2/3, I'm writing 3/2 on both sides. I'm going to multiply by that. The 3's cancel, the 2's cancel, which was our goal. P is by itself. Yay! And on the right side, again, I prefer to have 2 different fractions. And I end up with 315 for my final answer.